We've marveled at the achievements of the Apollo program, where brave astronauts first set foot on the moon. But now, we set our sights even higher, aiming to venture to Mars and beyond. However, such ambitious missions present us with an array of extraordinary challenges that demand our utmost creativity and perseverance. To embark on missions beyond the moon, we must overcome significant hurdles, starting with the cost and technological challenges that lie ahead. One major hurdle is the high cost involved in venturing into deep space. While the Apollo program cost approximately $25 billion to reach the moon, missions to more distant destinations, such as Mars, would be significantly more expensive, estimated to be at least 100 times that amount. This financial aspect presents a substantial barrier, as governments and companies must carefully consider the benefits of such missions against the immense costs involved. It requires a tremendous investment and global collaboration to make these ambitious missions a reality. Moreover, advanced technologies are crucial to support long-duration space travel. The current chemical rockets that have been utilized for moon missions are not efficient enough for longer trips to planets like Mars. As we look to explore further into the cosmos, we are developing more advanced propulsion systems, such as plasma or ion engines. These cutting-edge technologies offer improved efficiency and the capability to provide the necessary speed to reach other planets within a reasonable time frame. By developing and implementing these advanced propulsion systems, we are pushing the boundaries of what is possible in space exploration. These technological advancements will be instrumental in enabling us to traverse the vast distances and reach destinations beyond the moon. As we venture beyond the moon, a crucial concern that must be addressed is the issue of radiation exposure. In the vast expanse of deep space, astronauts face significantly higher levels of radiation compared to those experienced on Earth. During the relatively short missions to the moon, the astronauts were shielded by the spacecraft and special coatings that protected them from harmful radiation. However, during longer journeys to destinations like Mars, astronauts would be exposed to radiation from deep space, which poses a serious risk to their health. Exposure to high levels of radiation over months or even years can lead to long-term health problems, including an increased risk of cancer and DNA damage. To mitigate this risk, advanced radiation protection technologies are being developed. Scientists and engineers are exploring the use of radiation shields and shielding materials to provide enhanced protection for astronauts during extended periods in deep space. These innovative solutions aim to minimize the harmful effects of radiation and ensure the well-being of astronauts throughout their missions. While significant progress has been made, the development of effective radiation protection systems remains an ongoing challenge. Researchers are dedicated to finding solutions that can provide reliable and long-lasting protection against the hazards of deep space radiation. The safety and well-being of astronauts are paramount, and addressing the radiation problem is a critical step in making human-crewed missions beyond the moon a reality. When embarking on missions beyond the moon, ensuring a sustainable source of food, water, and life support systems becomes crucial. Unlike on Earth, where these resources are readily available, in the depths of space, astronauts must rely on advanced technologies to meet their basic needs. To address this challenge, a potential solution is to send cargo ships filled with essential supplies to the mission destination several months in advance. These cargo ships would act as a resource depot, stocking up on food, water, and other necessary equipment. This strategic planning allows astronauts to arrive later, carrying everything they need to sustain themselves during their extended stay. Developing advanced life support systems is a critical aspect of this endeavor. These systems would ensure the astronauts have a continuous supply of clean air and water. Innovative methods for water and air purification, as well as recycling technologies, are being researched to maximize resource utilization and minimize waste. Moreover, the ability to produce food in space is another essential component of long-duration missions. Scientists are exploring techniques such as hydroponics and aeroponics, which involve growing plants without soil, to provide fresh produce for the astronauts. This would reduce reliance on resupply missions from Earth and provide a sustainable food source. Communication plays a vital role in deep space missions, but it becomes increasingly challenging as astronauts venture farther from Earth. The vast distances between celestial bodies result in significant delays in real-time communication. For example, when Earth and Mars are at their farthest point, the delay in communication can be as long as 22 minutes. This communication delay poses several challenges for astronauts. It means that they cannot receive instant feedback, guidance, or support from mission control. In emergency situations or when making critical decisions, this delay can be a significant obstacle. Astronauts must rely on their training, expertise, and the resources available on board to handle unforeseen circumstances. Furthermore, the isolation astronauts experience during long-duration missions can have a profound psychological impact. Being cut off from regular contact with loved ones and the support networks they are accustomed to can lead to feelings of loneliness, homesickness, and even depression. To address these psychological challenges, astronauts undergo extensive mental preparation before their missions. They receive training to develop emotional stability, coping mechanisms, and strategies to maintain their mental well-being. Regular communication with mission control and ground support teams becomes vital in providing the necessary psychological support. Astronauts have access to resources such as video calls, emails, and other means of communication to stay connected with their families and loved ones. Additionally, regular check-ins and psychological evaluations help monitor and address any emerging concerns. Building a lunar base is an essential stage in our journey to explore the depths of space. The moon's surface is covered by a layer of regolith, which consists of dust and loose rocks. Scientists are investigating the possibility of utilizing this regolith to construct structures that can protect astronauts from radiation and provide a habitable environment. The regolith on the moon can be processed and transformed into building materials for various structures. These structures could serve as habitats, research facilities, and even power stations. By utilizing local resources, we can reduce the dependency on Earth for supplies and establish a sustainable presence on the moon. Building a lunar base presents numerous challenges that need to be addressed. Advanced construction techniques will be required to ensure the durability and stability of the structures in the harsh lunar environment. Power supply technologies, such as solar panels or nuclear energy, must be developed to meet the energy needs of the base. Life support systems will be crucial for providing astronauts with clean air, water, and waste management capabilities. Additionally, radiation protection systems will be essential to shield astronauts from the higher radiation levels on the lunar surface. This could involve incorporating shielding materials into the base's structure or creating underground habitats that provide natural protection from radiation. Establishing a lunar base would enable prolonged scientific research and serve as a starting point for future manned missions to other planets. It would provide a platform for testing and developing technologies that could support human exploration beyond the moon. By learning to live and work on the moon, we can gain valuable insights and experience that will contribute to our ability to explore and colonize other celestial bodies.